Hello everyone. Today we are going to learn about the 7 types of forces. So I am not here to give you notes. So these are your notes for today. So you do have a sub, and I hope that you guys will take notes on what you're seeing today. So what you see on here, please make sure to copy them down. There will be questions to answer about these and a couple of worksheets to do in the classroom. So today we're going to learn about the 7 types of forces. So we've learned about some of them already. So one of them that we have learned is if I have our force diagram, we have F with the letter G. So we call this force of gravity. Or we can even say this is force weight. So whatever the object weighs plus gravity pulling down on that object is what gives us this information here. And we said if it is laying on a flat surface, another one is force norm, or that means force normal. So if an object is resting and it is not falling down through the object, it is getting as much pushed back up as it is pushing down on the object. So they cancel each other out. So those are two: force gravity and force norm. If we now look at this object and we apply a force, so we push it, so we can be pushing it to go towards the right, and we can call this force push, meaning that we are pushing the object. Now, unless the surface is frictionless, there's going to be something counteracting it in the other direction. So in this case, I'm going to put a smaller arrow. So I'm showing magnitude here. By having a smaller arrow, it's showing that it's not as much force as the force of push, which is longer. So this F is going to be called force of friction. So F-R-I-C-T. So friction is the opposing force of push. So this is why we can't push something super easy across a surface unless it's frictionless. So that friction is causing it to slow down. All right, so what happens if we're pulling something across the floor instead of pushing it? So when we push it, it is often called an applied force, or we could say force push. In this case, we have a rope. So in this, we're going to say it is force tension. So force tension is what's happening on the rope. So it's creating tension and it is getting pulled. So this is called force of tension. We still can have force of friction applying because this is happening from the surface that it's gliding on. So the friction, again, works in the opposite direction of what we have with force of tension. In addition to force tension with just pulling on a rope, we can also have force of tension on a rope if we are using a pulley. So with a pulley, this helps reduce the amount of tension that's on that rope, making something easier to move. And in this case, our other objects are also being affected by force of gravity for this one down below, but there's nothing pulling it back up other than the force of tension from the rope. And then on the top box, we have force of friction affecting the box on the ground. And then we also have force of applied, or we can even say pull, because it is being pulled this way. So you can see in this, we have many different types of forces acting. So we have frictional force, we have an applied or pulled force, we have force of tension on the rope, and we have force of gravity affecting pulling down the object. All right, now let's look at an airplane. When an airplane is moving, the jet engines are causing a force that we can call applied again, or we can even call it a push because the engines are pushing the airplane to go this direction. On the other hand, we're not on a flat surface, but something is slowing down the airplane. So in this case, we say this is called force of air, and we abbreviate that to be for air resistance. So that means that we have a force, the air is slowing the airplane down in the opposite direction of the applied force. So if the airplane were to stop its engines, the air resistance would slow down the airplane. And if we did a free body diagram of this one, we'd have force applied, and in the other direction, we would have force of air resistance. Also, anytime we look at something that is falling from the sky, we have force and we use the G for gravity, so it's going down. But we also have another force that's going in the opposite direction as it's falling, which is our force of air. So our air resistance is keeping it from going super fast all the way down. So you could see this with example with a feather. If you drop a feather, it slowly comes down to the ground because the air resistance is acting in the opposite direction of gravity. The last force that we're going to talk about is force of spring. So anytime you have a spring and something is coming down off that spring, it is going to be applying upwards that force of spring. And then we still have gravity pulling it down. So we still have force of gravity coming down. So these are opposing forces. Okay, just to recap those 7, we have applied force, which can be a push or a pull. Gravitational force, which is the force that acts down on an object, bringing it towards Earth. Normal force that acts up on an object, keeping it from falling through at whatever surface it is sitting on. Frictional force, which is in the opposite direction of the applied force, so it slows the object down. Air resistance, which is for any object that is above the surface, whether it be in this direction, if the applied force is going like an airplane, or an object falling down, it would be the force going upward. Then we have tension force, which is anytime you have a force that's on a rope. And then spring force, which is anytime you have a force on a spring. Hope you guys found this tutorial helpful and that you guys can try out these new worksheets and see how you do on those diagrams. I'll see you guys on Tuesday. I hope you have a great weekend. Thank you.